Good morning, John. I can already hear the music building up beneath me, so I should probably just stop talking. This song is about quarks. I wrote it. It's called Strange Charm.
A quark is a fundamental constituent of matter, observed in 1968 through deep elastic scatter. And we found that protons aren't as simple as we thought. We thought they were solid particles, but they are not. Protons, in fact, are made up of three separate pieces. It just gets more confusing as our knowledge increases, but that is what a quark is. It's a piece of a proton, and they also make up other things, including a neutron. Oh, up, down, strange charm, top, bottom. If you don't know what a quark is, it don't matter, you still got them. And with leptons and bosons, unless something's amiss, they make up everything that we can see and that we know exists. Things made up of quarks, including protons and neutrons, are composite particles that physicists call hadrons. Many types of hadrons are theoretically described, but most exist for only very brief amounts of time. Quarks have electric charge, color, charge, mass, and spin, and having colored charge means they exist solely inside of other kinds of particles and cannot exist alone, which is why quarks have never been studied on their own. Up, down, strange charm, top, bottom. If you don't know what a quark is, it don't matter, you still got them. And with leptons and bosons, unless something's amiss, they make up everything that we can see and that we know exists. Quarks can join together in two different ways, baryons and mesons, but most instantly decay. If a particle has three quarks, then it's a baryon, and if there's one quark and an antiquark, then it is a meson. These tiny bits of matter are part of almost everything, and there is no unified theory to make it less confusing. But the fact that we've identified that they exist at all is so goddamn remarkable that I just sit in awe. Oh, up, down, strange charm, top, bottom. If you don't know what a quark is, it don't matter, you still got them. And with leptons and bosons, unless something's amiss, they make up everything that we can see and that we know exists.
Okay. That little song was an introduction to our last topic, and it is the standard model of physics. And our objective today is to be able to classify matter according to the standard model. So we have our electron, we have our atom actually, and we have our electron circling the nucleus. Where is the nucleus? Inside that nucleus are protons and neutrons, and inside a proton is something called a down quark, a gluon, and two up quarks. The neutron has similar things going on as well as the electron. So the classification of matter, as you know, can be reduced into atoms. An atom can be reduced into protons, neutrons, and electrons. And electrons cannot be reduced into anything smaller. In this context, they're called leptons. Protons and neutrons can be reduced into quarks, and they're called hadrons. Protons and neutrons are made of three quarks. So in the electron cloud that surrounds the nucleus, in the nucleus we have protons and neutrons. A proton is a down quark and two up quarks. So it's up, up, down. This we can call the particle zoo. This is on your reference table, at least in part. And the kind of matter that makes up the stuff you and I interact with is made up of particles in the first column, up, down, and electron. So we have up, down, and electron. This is the stuff we deal with. The second and third columns here, topped with charm and top quarks, they existed in the Big Bang, pretty much, and in particle accelerators. They don't really last very long. The last two columns are bosons, so we don't really talk about bosons. So this is in the reference table. This chart right here is in the reference table. Matter is broken down into leptons and hadrons. Leptons are electrons. They can't be broken down any further. They're already really small. Hadrons can be broken down into smaller parts. Baryons are protons and neutrons. They come in three quarks, and they add up to the charge of that particle. So a proton has a charge of +1, so it's up, up, down. So plus 2/3, plus 2/3, minus 1/3 gives you +1. A neutron must equal to 0, so it's an up, down, down. So plus 2/3, minus 1/3, minus 1/3 is equal to 0. Up is an up quark with a value of plus 2/3, and down is a down quark with a value of minus 1/3. Antimatter is exactly the same as regular matter, except its charge has been reversed. When a particle and its corresponding antiparticle touch, they annihilate. Annihilate means they disappear, and they release energy according to E equals mc squared. So an electron and an anti-electron, aka a positron, protons and antiprotons, and neutrons and antineutrons. Okay, and here we can look at the Higgs boson. A quick cartoon.
Ever since the accelerator turned on, like a year ago, it's been really totally crazy here. Because everybody comes and sends their students, and it's the center of the world for particle physics. Things have been running really smoothly. The accelerator's working really well, it's going really fast, we're getting a lot of data. So everybody's really excited. We can discover something any moment. You can hear about some amazing discovery. We're always looking at the data wondering, like, what's going to pop out of it. Who knows what, right? This is when, last time we talked about surprises, this is when the surprises might happen. So any day could be the day that changed the world. The LHC is it's really all about discovery and exploration. We're looking for
LHC
different
is the
kinds of
Large
things,
Hadron
new
Collider.
crazy kinds of things. I mean, to make up everyday matter, you only need the electron, the up quark, and the down quark. Because with the up quark and the down quark, you can make a proton, or you can make a neutron, right? Electrons and protons and neutrons, you can make any atom. So you only need these three. But there's, how many particles are there we've discovered? 12? Why do we have them? I don't know. How many are there? 100? A million?
And with that, I will stop. You can watch the rest on your own if you'd like. Okay? Thank you.